In this video, we're going to work a few more examples of finding dy over dx using implicit differentiation. So number one, let's look at y cubed plus sine of y equals x squared plus y. And so we want to find dy dx using implicit differentiation. Alright, so what we're going to do is we're going to differentiate each term with respect to x. And remember, when you differentiate a function of y, you need to include that factor of dy dx. Alright, so here, y cubed, that's going to give us 3y squared dy over dx plus cosine of y, also times dy over dx, equals 2x plus 1 dy over dx. Now, what we need to do is solve for dy dx. So what you need to do is collect all the terms with dy dx on one side and all the terms without dy dx on the other side. So what we need to do is, in this case, take this term and move it over here. And that'll give us 3y squared dy over dx plus cosine of y dy over dx minus 1 dy over dx equals 2y. And now we have about two more steps. We need to take out a common factor of dy dx from every term on the left. And we've got dy over dx times the quantity 3y squared plus cosine y minus 1 equals 2x. And now divide each side by 3y squared plus cosine y minus 1, and we're finished. There we go. Alright, well, let's work one more example. Let's try x sine y minus x squared equals cosine of x squared y cubed. And the instructions are the same. Find dy dx using implicit differentiation. Alright, so we're going to differentiate each term with respect to x. Now, when I say terms, you need to make sure that you know what I'm saying. Terms are separated by pluses and minuses. So this is a term, that's a term, and that's a term. This term has a function of x and a function of y in it. And they're multiplied together. So what we need to do is use the product rule. Alright, so we'll have the first factor times the derivative of the second plus the second times the derivative of the first. So we'll have x cosine y. Now, we just differentiated a function of y, so we need to include dy over dx. Plus sine y times the derivative of x, which is just 1. We do not need a dy dx term in this factor in this term because we did not differentiate a function of y. We differentiated a function of x. We don't need a dy dx when we differentiate x squared. It's a function of x. All right. And then we go on to the right side. So we've got actually a composition of functions and another product. So let's see. Differentiate the outside function, and that'll be minus sine of x squared y cubed. And we need to multiply this by the derivative of the inside function, which is going to require us to use the product rule. All right, so we'll have x squared times the derivative of y cubed, which would be 3y squared dy dx plus y cubed times 2x. And I ran out of room on that line. Okay. So we need to separate out the dy dx terms and get them on one side. So what we're going to have to do is distribute this minus sine x squared y cubed across this sum so that we'll be able to isolate the dy dx terms. So let's get started with that. We'll have x cosine y dy dx plus sine of y minus 2x equals minus sine of x squared y cubed times 3x squared y squared dy dx. And now we need to multiply the y cubed 2x by the negative sine x squared y cubed. So that would be minus sine x squared y cubed times 2x y cubed. Now we can pull all the dy dx terms over to one side and pull everything else over to the other side, and we will be almost done. So I think I'm going to pull all the dy dx terms over to this side. So let's move this term over here and take these two terms and put them over here. So we've got x cosine y dy dx plus 3x squared y squared sine of x squared y cubed dy dx equals 2x minus sine y minus 2xy cubed sine of x squared y cubed. Now all we have to do is factor the dy dx out and divide, and we'll be done. So we've got dy dx times x cosine y plus 3x squared y squared sine of x squared y cubed equals 2x minus sine y minus 2xy cubed times the sine of the quantity x squared y cubed. And now all we have to do is just divide each side by the coefficient of dy dx, and we'll be done. And actually I think I'm going to save myself some writing and just move this over here. That's sort of cheating, but I'm out of paper. I'm at the very bottom of the page, so we'll just strike that out. And there's our answer.